Welcome to today's session. So, in this session, we are going to cover Redis concepts and various caching mechanisms and how Redis uh, increases the speed and Redis CLI commands and many more things. Okay, all these things I am going to cover in this 3.5 hours session. I will be covering end to end. All the details will be covered. So let me share my screen. Redis is a very popular database. It is an in-memory database, and all the things will be discussed in this three and a half minutes workshop. Okay, first, before we begin, we need to understand some important concepts. Okay, what is system design? System design, like there are many, like in the current market, there are many popular systems like Netflix, Uber, so and Razorpay. Like there are many popular applications. I mean, they have designed their systems. So this particular Redis will come under system design domain. In software engineering, we have various domains like web development and cloud computing, artificial intelligence, machine learning, okay, and cyber security, okay, like that, and deep neural networks, deep learning, and DevOps. Okay, so there are various branches or domains in software engineering, and this particular Redis comes under system design domain. And so, okay, so Redis comes under system design domain. In system design, because these things are necessary, because you have to understand the entire ecosystem to play the role normally. So this particular Redis comes under system design ecosystem. Okay, so whenever you are using a particular technology, you have to understand the entire ecosystem and how the particular technology is playing that role in the particular ecosystem. So, when if you consider system design, within that system design, there are uh, various concepts and various mechanisms. Like, for example, system design is broadly classified into two. One is high level design and low level design. Okay. System design is broadly classified into two. One is high level design and the other one is low level design. Within the high level design, what are the things that comes? Okay. I'm not going into all those things, but these things forms the foundation. Unless the foundation is not strong, we will catch some things, but we won't be able to implement or we won't be able to master like monolithic architecture, multi-tech architecture, microservices architecture. Okay, all these architectures comes under high-level design. And also, what is load balancer? Okay, and what are message queues? Okay, all these things come under high-level design. In low-level design, okay, uh, let me put this. Redis also comes under high-level design. Various architectures which I have mentioned, like monolithic architecture, what is multi-tier architecture, what is microservice architecture, okay, and this the load balancers, okay, and message queues. All these things come under high-level design. In low-level design, oops, okay, and in low-level APIs, application programming interface. APIs which are very broadly, very frequently developers use, like Google Maps is one example for API. Okay, these things come under high-level design, and these things come under low-level design. System design is broadly classified into high-level design and low-level design, and our Redis comes under high-level design. It is part of high-level design. Because when you want to design a system which is very efficient, very uh, user friendly, and all these things to design a system, or to model a system, it requires lot of design, right? So that is the system design. So Redis comes under system design domain, and caching mechanism, whatever is required, that particular related thing, that part will be, I mean, it will play the particular role in the system design ecosystem. Now, next thing is what is difference between SQL and NoSQL databases, right? For example, our Oracle, PostgreSQL, and MySQL, these are all our traditional relational databases. Okay, all these things come under SQL, whereas Cassandra and DynamoDB and MongoDB, and including our Redis. These things comes under NoSQL databases. Why? Because NoSQL stands for not only SQL. So this is also important to know why only Redis, like why Redis, right? That we have to know, because there are certain challenges that we encounter when we are using the traditional relational databases. Depends on the requirement. In specific requirement, I mean, Redis plays this NoSQL databases plays major role compared to traditional relational databases with rows and columns and all. Okay, but in some other requirements, wherein NoSQL databases plays the crucial role. So it depends on the entirely depends on the requirement. Now coming to, yeah, here few more things, like for example in SQL it is relational, in our relational traditional relational databases, where it is data is in the form of rows and columns. Okay, but in case of NoSQL databases, it varies. For example, in case of MongoDB, in case of MongoDB, it is document-based database, and wherein JSON, data is stored in the form of JSON. Okay. However, it varies. Like DynamoDB again different, and Cassandra again different. In case of Redis, the data is stored in the form of key value pair. Okay, entire data is stored in the form of key value pair. So that is easy, right? Just with few commands. I mean, in case of traditional relational database, you have to write a big query, select star from table name, where equal to, column equal to so and so something. So, and we have joins, all these things. But in case of Redis, you just, I want that. Okay. I mean, there is no thinking from the database perspective. Database doesn't need to process it. For example, in case of the select query, there will be execution plan. It will, there is administration, lot of administration is there. Like it prepares the execution plan. If required, it will summarize the query, and each statement. Many things are there. So that is all comes under database administration. So, but in case of, if when case of NoSQL databases, it is just the key value. I mean, depends on your database. In case of Redis, it is just the key value pair, and just with one command, I want that, and immediately, like I want the value of that particular name. For example, here name, name Subhash. This is one entry in our part1 string, something we have entered in our Redis database. So just with few commands, let us say now get name. With just one command, you can get the value of that particular key. Okay. So that is the benefit of the NoSQL databases, and some more discussion is required, which will be coming in the later slides. And next comes caching strategies. Okay. Here, in caching strategies, there are various caching strategies. I mean, these are, we are still not getting to the Redis actually. These are all things which we need to know. Caching strategies like read through, write through, okay, and cache aside. Like that, there are some caching strategies. Like for example, first database hits the, like one strategy. First, the application hits the cache, If it is not present in cache, then if it is present in cache, it will return that particular thing to the user. If it is not present in the cache, it will hit the database, whether it is Snowflake or Oracle or whatever, and it will return. I mean, it will return it, and also it will store in that particular cache. That is cache asset. Like that, there are various caching strategies also there. Okay. Just this is one thing to know. I mean, even if we are not aware previously. So, what are those caching strategies? Broadly, there are five are there. Let me write it down. Cache aside, read through, write through, okay, and yeah, write back and write around. So, there are various caching strategies, and I mean, using those, we will be learning those caching strategies as well in our workshop today. Now comes stateless versus stateful. What is stateless and what is stateful? Very, very important. Let me explain through some example. Simple, stateful means it remembers the state where you left off. Okay, it has to remember. It actually, I would say here I mentioned as services, maybe architecture kind of thing. So no need to mention services. Generally, when we are defining or when we are designing a system, we should know which one to use. Whether should I proceed with stateless or whether should I proceed with stateful. So what are these things? First, to understand the meaning, stateful, if you are like considering the option, then your application or your application has to, or your server has to remember the state of that particular user. Stateful means remember that state. Stateless means even if you don't remember, it will not mean much. It will not impact. That is the difference. Like for example, um, okay. So user one, user two, user three, and each one is accessing. User one is accessing server one. User two is accessing server two. User three is accessing data from server three. Okay. Now let us assume if server three has gone down. Server 3 got some issues. Okay, server 3 got down. Server is down. Now, what the user's session, his profile, all these things are present with server 3. Then, when the user tries to connect to server 2, server 2 do not know who is this particular user. Okay, this is stateful. Okay, this is stateful. Why? Because in this kind of setup, this particular server has to remember that particular user. If it doesn't remember, uh, I mean, then I mean we cannot render service. We cannot do service to that particular end user, right? Example. Like for example, in case of YouTube streaming, I don't prefer YouTube, but in case of a streaming application, in our, let us say in olden days, You were watching some video in the television, okay, and you paused that video in television and you started that video in not television, LCD. So you started again that particular video in your mobile phone. What will happen? The mobile will not remember. The mobile will not external device. Here these are server, but your external device don't have clue. So it will start the particular video from the beginning. Okay, so this kind of setup comes under stateful. Now, in contrast, let me keep this, not erase this. In contrast, stateless. Like for example, in our Netflix and all. So if you pause that particular Netflix, it remembers where you left off. The user, you watch till 15 minutes, let us say. So the user, the application or something will remember the session or that particular user where he left off. Netflix system design was like that. Is like that. So how it can be possible? Let us say same case, user 1, user 2, user 3. Okay. So all these servers will S1, S2, S3. All these servers will okay, all these servers will write to common database. Here, each server will have its own database, but here all servers will write to common database, and that's how that kind of synchronization is achieved in case of stateless. So depends on the requirement, we use sometimes stateful, sometimes stateless. Okay. In a nutshell, stateful means the application or the server has to remember that particular user or session. In stateless, the application or server does not have to remember the user session or user profile. And now come another example that usually you will find in the internet. It is something like you went to a restaurant wherein you order something to the waiter, and the waiter by chance he left. His time is out and he left. So the waiter doesn't remember your menu, your whatever you have ordered. So they maintain the, let us say now all the waiters are maintaining one what is the notepad kind of thing. They are maintaining some single notepad and they are writing into that particular notepad. So even if one waiter left, so that this is the example you find in most of the internet places. So that's why I'm referring. So the even if the waiter left in the middle, other waiter can pick up that particular thing from the menu and he can serve the food. So this is the difference between stateless and stateful. Stateful means remembering the state. Stateless means doesn't have to remember the state. Any doubts still not? Okay. Let me let me proceed to the next thing. Throughput latency. Or maybe you already know all these things and I'm just repeating.
Yeah, yeah, yeah.
Okay, no problem. Uh, Okay, from my side, I am clear. In this clear enough, I will be completing all the Redis with no doubts. Okay, all your doubts for regarding Redis will be clear. That is
Okay.
my right. You can ensure. So now throughput and latency. So uh, in case of traditional databases like Snowflake or Oracle or these relational databases, we call it as throughput. In case of Redis, we don't call throughput, we call it as latency. Because Redis, how many rows per second it is processing, right? That is the thing. But here, latency, like how quickly it is caching it. And by the way, Redis comes under stateful. Redis is a stateful, it remembers that particular thing. Some places it is called stateless because it is temporary and volatile. But however, it is a stateful architecture. So this asynchronous replication, which Redis, in case of Redis, we like for example when we use the master slave architecture, when we come to its later point, we have to know this asynchronous replication. I will go through that in detail, but this is the an important technology that we need to be aware. Okay, so these are all the before we begin, we need to understand this to have a solid foundation for the upcoming, slides or workshop. So what all the things will be covered as part of this workshop? Redis at a glance. Okay, I have one slide wherein you will have all the things which are mentioned here. All these things in single slide, it is there. So I just present that particular thing. And then how to install in Unix, in Windows, in Linux, in all three environments. I will share the comments. You can install, but since I am using MacBook, I will show you how to install and uninstall in MacBook. In Windows also, I will explain. No need to worry. Okay, how installing Redis and introduction to Redis. Okay, already we discussed, but I will be covering this thing. And architectures, here it comes master slave architecture and cluster type of architecture. All these things it will come here. And data structures. Redis supports a lot of data structures like strings, lists, sets, sorted sets, and hashes. Okay, and streams. All these data structures, we will go through that in detail. I will execute the commands and I will show. And yeah, Redis commands and Redis streams. Redis as a cache. How we are using the configuring Redis as a cache. This thing will be covered. And Redis pubsub. Yeah, subscriber and publisher. How we when we publish the messages, how other subscriber can it will reflect in other subscriber. This thing also I will demonstrate. Next thing, these two are extremely very important, and this is also the requirement for this workshop. So one is persistence and another is high availability. Okay, as part of persistence, AOF and RDB. Okay, these things will be covered as part of high availability. Again, release Sentinel. So those topics with demonstration, it will be completed. After this, you will have the real world integration. So from Python script, because you just design the system with Redis won't help, right? Within that system, we need to call the Redis client, and you have to from the from the Python code how you are uh, calling the Redis, how you are performing operations. This thing also I will be covering in this particular workshop. Okay, this is the agenda of this entire. I hope I covered everything. Yeah, only thing is Lua scripts. This I will think about it. Uh, Whether I will be covering or not depends on the time perspective, time constraints, because actually every month end becomes, this is something personal, becomes little anxiety because I have to, conduct workshops and within our team, I am only giving salary. So many factors are there. Like we are going to conduct probably one workshop in one college, and we have to discuss with one client that will be developing some applications for them, either mobile app or website or whatever. So many things are there actually. So I will think about it. I will see. I will try my best to cover these aspects as well. However, all these things will be covered as part of today's as part of the workshop.
Okay.
So Redis actually it is a short form for remote dictionary server. Remote dictionary server. Short form is Redis. REDIS. So I mentioned this one because this slide I wanted to present because it has all the things captured in a single slide. For example, data types is covered, right? String, bitmap, bitfield, hash, uh, list set, sorted set, all these things are covered here. And coming to this part, Redis persistence, right? AOF and RDB. Redis, how it is doing the backup and database backup and append only file. All these things are covered here. And coming to this one, like in a simple your machine, if you want to set up Redis, you want to install, how you do this one. And high availability. Uh, you have to replicate the slave as per the master. So that is there here. And sentinel nodes. Okay, Redis cluster. Now, yeah, here again, what will happen when you in what will happen when you are trying to, this is something it is internal. What will happen when you are exactly replica, when we are creating the replica, what is happening? How that particular slave is actually keeping that copy. Both should have same copy. This thing will come up. Okay, in the architectures, this thing will come up. How master is having the copy of that particular copy of is having the data, and slave also maintains the same copy of the data. How exactly internally what exactly happens, right? Fork is actually Unix. It is a Unix system call which is used to create the duplicate and all. So this is something internal. So this is also covered, and this is the how the way Redis in general functions. Traditionally in general, how Redis functions. Okay, this is cache aside. In the beginning, we have discussed the caching strategies, 5 caching strategies. So, in case of cache aside, how, this is the way Redis works. Let us quickly check. So, client is trying to access something, is requesting something from the server. Now, first it will look into the cache. First, it will look into the cache. If it is available, immediately, I mean, client will get his response. Nothing to, bother. But in case of miss, that is called as hit. Okay, hit. Now, in case of miss, it has to look to the backend database, and the details will be sent as a response to the client. However, Redis also maintains that particular once that particular miss, it will again cache into that particular whatever missed, it will cache into that particular database, and it will deliver that particular response to the client. This is the way Redis simple Redis setup exactly works. So this slide I have just put because it is capturing everything in a single slide. So these are all the various data types. These data types also I will be demonstrating. Uh, yeah. Okay. How to install and uninstall Redis? Let me share my screen. MacBook. Before I go to MacBook, probably most of the people uses Windows, right? So these are all the three methods you can install Redis: method 1, method 2, and method 3. However, method 1 is not recommended. If you go to Google and type Redis for Windows GitHub, okay, you will get one MSI, Microsoft installer. But this is not recommended because some latest features are, I mean, you will miss the latest features. Okay, so this is one way to install, but don't proceed with this thing. Method 2 and method 3, anything would be fine. However, method 3 is recommended. Method 3, you have to install Ubuntu in Windows. Okay, so for that, nothing to, I mean, in your PowerShell or command prompt, you just have to give WSL hyphen hyphen install or WSL install. WSL stands for Windows Subsystem for Linux. Once you give this thing, this command, okay, the Ubuntu or Linux will get installed. Then you just have to same commands that you run in Linux, you have to run here also. Okay, same commands. This is one way to install. I mean, whatever is feasible, you can proceed. Uh, Method 2 or method 3, anything should be fine. All the commands are there here. As I said, I am using MacBook, so I will show you, I will demonstrate the install and uninstall from MacBook. And in Windows, if I have to demonstrate, then I have to switch the machine, all these things I have to do. And it will take some few minutes. So using this, I tried in my Windows laptop as well. So these commands will perfectly work. You don't need to worry. So first in method 3, first we will be installing the Ubuntu or Windows subsystem for Linux. Then you will be running the same Linux commands here. Okay. Then Redis will be installed. Just few more points. Here, sudo stands for super user do. And apt or apt-get. So apt-get, both are same. Okay, here apt-get is there, and apt both are same. Apt covers both apt-get and everything also. So you can use the apt also here also, even if you have Linux already as a virtual machine or something partition and you are using Linux also, let us say. Then even here instead of apt-get you can use the apt. This is a package manager, just like NSM, NPM in case of Node, Java, Windows, or Brew, Home Brew. Okay, these are all the package managers. They will connect to that particular repository and they will download and install it. Okay. However, before installing, you have to run the update command. Why you have to run the update? Because sometimes it refers to the because In case of Redis, this command is not required. Okay. In case of Redis, this update command is not required because by default, the Redis who has developed the technology or software, he will be pushing that latest thing to you. Just you run the sudo apt install Redis server, the Redis latest version will be pushed. But however, in some cases, some other technologies or something, wherein you won't get the latest version. So in that case, first you need to run the update command, then you can run the install. Okay, this is method 2. Now coming to Docker method, first you have to install the Docker desktop in your Windows. Okay, before this step, I mean, I did not mention those steps because then again the list would be heavy and I mean it doesn't come under presentation some kind of thing. So first you have to install Docker desktop. Very easy. In 5 minutes or 3 4 minutes you can install Redis. Not a problem. Okay. So first we have to install Docker desktop. Once Docker desktop is installed, keep it in the running. You run the Docker desktop, then you run these commands. Okay. Here I mentioned our organization, but you can name anything. You can give some other name also. So once you run these two, then this is sufficient. Okay. Uh, This command is sufficient to install Redis. This one is you want to access the CLI command interface if you want to access. This is the command. So these two commands. I will share this PPT and both Excel sheet which I have. Both I will share. Okay,
Okay,
I
for
will.
method 3, like, do we need to, like, for method 3, directly we can install in Windows Server or we need to install anything else before that?
Method 3, you just have to install Ubuntu.
When do we have to
Repeat.
install? Okay.
But yeah, Ubuntu means Linux. This is just in command prompt. You run the this one I prefer. I mean, I recommend it. So you just run this command within within few seconds. Linux will be installed. Windows subsystem for
Mm.
Linux and Linux prompt will appear. Then you run these Linux commands.
Okay, okay, got it. Okay.
In Mac, I will demonstrate the installing and uninstalling. So all these commands I will be sharing with you. And yeah, for installation and these are all the commands. Okay, now uh, for in case of yeah, Redis 8.6.2 is the latest version which is currently in the market. And whatever the commands that I am giving here, this thing is also present in the Redis official portal. Something is there. Yeah, Redis is not IO. Here, Redis are IO slash downloads. Something is there. So these steps are there. Okay, yeah, see here. It is open source 8.6. Download if you click, it will be redirected to this particular page, and you can refer here as well. I just consolidated things so that everything is in one place. If you go to APT, you will have these Linux comments, everything. And home is for Mac. And in Windows, you will see the Docker comments. Okay. Run Redis open source on Windows Docker. So you don't have to, I mean, no commands are listed here. You just have to go to Docker, then install the Docker desktop in your local and execute this Docker commands. Okay. So, and I think you already knew Redis by default uses 6379 port. Okay, like for example, Redis. Now I have installed Redis in my MacBook. It is 8.6.2 version, and now start services. I think I will try the message. Yeah, Redis by default uses 6379 port. By this point you might have aware, you might be already aware. So it is something like in your this is the logical port. In your in our laptops we will have a port. I mean, if you want to insert USB device, pen drive or something, then there is one port. But if you want to insert laptop charger or power internet cable, let us say, then there is another port. In the same way, just like how the port serves specific purposes, similarly in networking also we will have the logical ports. Each port is specified to certain service. It can be any other any service. Now, Redis by default uses 6379 port. However, you can configure it for some other port, which is I mean, which is free in your application or system or laptop or whatever where you are using. So, introduction to Redis. Definition we already discussed in the previous slides. Redis is an in-memory database. Okay. In-memory database, it use this it will be used as database, cache, and message broker. Okay, all these three purposes it will be used, and it is an open source. Okay, so now this one I already explained. This is how Redis is typically used. It will look into the cache. If it is there in the cache, it will return immediately. If in case of miss, then if in case of miss, then it will hit the backend database, which is archive, which is the main database. Then it will return to the client, and it will also update its cache. So this is the way, and Redis is used.
Okay, for Redis, like always, there will be a backend database, SQL one.
Yes,
Okay.
backend we have, yeah, I mean, Redis is just a, and it is in memory. In memory in the sense it will be stored in the RAM. That is why it is very,
Hmm.
very fast. However,
Yeah.
yeah, however, you have to, I mean, data has to be there in the hard disk, and uh, data, we should not lose the data. So, both are required. That is why Redis is the comes in the system design domain where you have the, I did not put that slide. You will have the application layer, you will have the UI layer, all these things will be there. Between that application and backend database, Redis will come actually. All doubts will be clear. I will be demonstrating it. So both are required. With Redis alone, we cannot, it is not, I mean, I don't know, depends on the requirement maybe, but on most system we will dual with cache alone. So it works by keeping all the memory in systems RAM rather than on slow hard drives, allowing for sub-millisecond response times. Very, very fast, the response will come. While primarily memory-based, it can periodically persist data to disk to prevent loss during a reboot. This is Redis persistence, which will be coming in the later slides. But however, on a time-to-time basis, it will write the data to disk. And in case of reboots and all, it will not lose the data, right? So it will write the data to disk. And it supports various data structures like strings, lists, sets, making it highly versatile for real-time applications. Simple introduction. Now, yeah, this is something which has to be, uh, I mean, at least for understanding purposes, we have to know why we are using Redis. So, in case of traditional relational databases, as I mentioned in the beginning, the database has to process that particular query. It has to, like, it can be like, for example, query execution plan. It has to prepare many data, and it will also, there are um, various blocks are there. I know block and many blocks are there in our database, database administration. So, lot of things are there. So, slow reads, right? And you have to sometimes multiple tables you have to join. Okay, let me demonstrate through some simple example. Uh, this is important, very important, as like in the entire ecosystem, how crucial role Redis is playing. I explained in theory, like for example, I won't take much time because lot of subject is there. Serial number, name, and okay, mm, phone number and address. So let us say these are the, I mean, in your initial table has these columns, okay? But later, uh, new requirement is coming, something like you have to store the office number and work number, okay? And in case of address, you have to store the email address and normal address. And within the normal address, also we have to split it like zip code and city, all these things we have to split it. So in such cases, what we will be doing? We will do normalization. So it will something like that. This serial number and name, okay, phone number, something, right? Mobile phone, okay, work phone, I mean work number, and you just have to put the serial number here. You don't need all those columns. So this is one small table, and for address, another table will come. Okay, like that. So we will do the normalization, like the first NFC, two NFC, three NFC, boycott number, whatever. And if you need from both the tables various information, you have to join the tables. I mean, see, as the requirement goes, how the complexity is increasing. That is the point we have to catch here. So now, Redis, there is no such a thing. Like even if what can be the case, you write just to take one hash. I mean, I will explain later on. Hash data type, and it is almost like a dictionary in Python. So uh, now serial number one, name wash, phone number 19, okay, and address. This is the initial state of the record or data. Address Hyderabad. So later this requirement has come. Please add the work phone number. Please add the, okay, address, zip code, and all these things. So we will be keep on adding that thing here, like zip code 500084 and one phone number equal to 040 or 080 something. So it is as simple as that. And I mean, first of all, there is no separate creation of table. There is no normalization. There is no. I mean, I'm not saying missing anything here, but it is very simple inserting into the hash, and it is very simple commands to fetch the data. Okay, just using hget. Okay, you can get the particular whatever you want. You want the work phone number, you can get it. So that is how Redis simplifies these things. So and used as a uh, between database and the application, it uses the intermediary cache and speeds up the things. So here heavy joins, high latency. Whereas in case of Redis, it is ultra fast access, reduces DB load and better scalability. Okay, you can upscale, downscale, you can even delete the particular hash storage, whatever data storage, data type. So like that, the key basically, you can delete the key. You can again create it. So you can increase the values, decrease the values. So there is a lot of scalability. So same thing mentioned here mostly. So it is transactions, it is caching purposes, it is structured, it is schemaless. Yeah, it is moderate and it is very fast. Okay, so I mean, why I am explaining this? So for better visualization, I mean the crucial role that Redis is playing in the entire uh, ecosystem, system design ecosystem. Architectures will again come. So yeah, I will be covering very brief and then I will go into the data types and comments. So architectures, uh, traditional client-server architecture. When the internet came into picture, internet evolved, client-server architecture became the, it became the need. So, however, what is the challenges that we face in the client-server architecture? So, server client, and if one server goes down, then these clients have to sit idle or they have to wait for the server to work. All these things are there. And another case, there can be lot of requests. All the requests coming to single server. Okay, so overloading. That is also one challenge. Like that, there are few challenges in the client server traditional. So here, in case of Redis, I mean, master slave is definitely not. I mean, however, it is something like uh, enhancing your I mean, traditional client server. It is not replacing because here also you need the clients and server. But this kind of multi-slave architecture, it will uh, uh, eases the things, simplifies the things. Okay, now how we are overcoming these challenges in our master-slave architecture, right? So that is what I mentioned in the beginning, asynchronous replication. I will be covering like in the beginning, I just mentioned the term. Now probably I will be explaining some 20-25%, and whatever remaining things will be covered when we discuss high availability in those concepts and when I am demonstrating, those things will become clear. Now, how these challenges will be overcome in master slave? Hmm. In case of master slave, we like for example, this is the server, right? And these are clients. So we create the replica of this particular server. Okay, this is slave and this is master. So and whatever data is maintained in the slave as well. Okay, another copy of data. I mean everything like whatever data that the master is having, that slave is also maintaining that particular copy of the data. Okay. Let's see. Whatever copy of data is maintained in the slave as well. Now it is very, I mean, how it maintains, I will explain. Now, I mean, you can, for writing purposes, you can go, I mean, you can interact with the master, and for reading purposes, you can, I mean, connect to the slave. Okay, this is the master slave architecture with which these challenges, like even if, for example, master goes down, all these clients can connect to the slave. And I mean, there is no latency, there is no missing of data, there is no, I mean, nothing. Like everything application runs smooth.
So
So,
how basically this data replication happens? Because generally, like it will stored as a .rdb file, right? So the same file will not be present in the slave.
okay, okay, got it. Uh, Same file will be okay. First, let me explain how internally it happens. First of all, uh, whenever the request comes to the master, it yeah, it creates that copy. I mean, for example, some insert statement or something which is filed by the some new data is coming. So not only it processes that thing, but it also, I mean, one copy of the data, it is sent to the slave. So one copy of data is sent to the slave. Now it is the slave's responsibility to what the slave does. This is the first step. Uh, okay, for your quick answer, RDB file has to be present in the slave as well. I mean that file. Let me complete. Now, as a second step, what the slave does, it clears off its RAM. It clears off its RAM and it has to loads the file. Whatever is sent by the master, it has to load that particular file. Slave has to load that particular file. And third step, uh, now what if there is some disconnectivity? Okay. So in case of disconnectivity, a buffer will be there. Okay. I actually in our system, this is not completely in place. not completely in place, but I can, I mean, I will demonstrate, okay? I have time to tomorrow and I will demonstrate. Again, that's why I'm just explaining high level, around 25% and some. Whatever pending things, I will be completing tomorrow. I was preoccupied with other things and I could not actually even complete the PPT also for the workshop. No issue. There will be a buffer. In case of any delay, third case, the master will keep that particular file in the buffer. Like for example, slave is down or something. Keep the file in the buffer, and whenever the slave is up, it will take the file from the master and it will pause. I mean, it will again does the same thing. It will clear some stack and it will uh, loads the particular file. So, uh, are you sure that that file has to be there in both places, both in master and in slave? That copy whatever the master is sending or the request insert or something that has to be stored in both places. Uh, this is the how the master slave architecture works. It is not something like I mean, replacing traditional client server. There has to be client server, and I will demonstrate in my AWS machines. I mean, AWS we have instances. Okay, Linux, Windows instances are there. I will demonstrate. And I will coming back to your thing. So this is not a replacement for traditional client server. We need client server. However, this kind of master slave is architecture is overcoming those kind of challenges wherein server goes down or high down. Okay, in all these challenges uh, will be overcome in this master slave architecture. Still, I have not yet come to the Redis cluster. Redis cluster also, I think really I will mention. So coming to the clustering architecture, data is stored in form of clusters. Okay, so these are all the architectures. Now coming to data structures, we have time. Okay, so today I will try to cover as many data structures as possible. Redis supports all the data structures, strings, hashes, and sets. Hashes are like dictionaries in Python. Okay, and sets are also, I mean, it will have unique values. That is the only difference. Lists are same. I mean, in Python, lists are there, arrays, right? Same here also. Sorted sets, streams, bitmaps, bitfields, hyperlog, and geospatial. So all these data structures Redis supports. Okay. So let me quickly jump into the commands. You are familiar with the Redis CLI commands as well, or you have not tried it?
Yeah, yeah, I'm familiar how to connect to Redis client and
Hmm.
just like some things like how to get the key name, how to delete the keys, like few things only we use. That those
Okay,
things
no.
only I'm familiar. Yeah.
Okay, so what about lists, pushing, popping, and in hashes? How about multiple set, multiple get, and many things
No,
are there.
that I am not aware. No, I am not aware of that.
Okay, okay, no problem. No issue. That's why I would like I will quickly cover those things as well. Laptop or whatever where you are using. So you can use some other port also. Um, only just to I mean you just make sure. that port is not being used by some other service. Okay, then we can use that port. Now coming to this is local host 127.0.0.1. This is called as local host. Whenever you are uh, whenever you are in your local machine, you will see this particular IP address. I mean, this IP address is local host. For your laptop, you should have some IP address when you connect to internet, or you will need some network. So this is I mean, default IP address for local host. So that is why it is showing these two. Now local host and port number. Now you already knew set and get commands. However, for the recording purposes, just once or twice I will execute those commands. For the first, immediately, let us see, since this is the first time I install, keys won't be there. However, let me quickly check. Achha, I have uninstalled installed. Already some keys are there. One is the country key and another one is student key. Now, how will you, I want to see the key, okay, student, which I created. Uh, uh, Okay, so here it is saying wrong type operation against the key holding wrong kind of value. So from I need to know what is its data type. If it is a hash, I cannot proceed with the get command. Okay, I will be so I am using the type command. Purpose of this type command is to know which data type or which data structure that particular key is. So here student is hash data structure. Hash is similar to dictionaries in Python. And let me also see what is the country. Country is a list. Okay. Now without any further dwelling into those things, let me create one string quickly. I will not take more time, just 1 minute only. String uh, new I will put workshop, okay, and Redis get workshop. So I have created a string workshop. I mean, this is the key and this is the value. So this is the string commands set, get, and few more are there. I have let me um, okay, delete. Okay, no issue. Suppose this is for setting, I mean, creating a string data type. String, I mean, data type key and value pair. Now, to get that value, what is there in that particular key, we use the get command. Now, I want to delete this key, whatever I created. So, we use the delete command. Here, if you are already aware, that is good. But if you are not aware, this one indicates positive, true, that kind of result. Zero indicates, for example, I am using again Dell workshop, it will return zero. Why? Because there is no such a key. Already that key is deleted from the database. So why this is why this kind of development in for Redis, because already Redis is purpose is in our database and to speed increase the speed and fastness. So if it is a numerical value, 1 or 0 is the like foundation, right? I mean computers starting with ones and zeros. So returning 1 and 0 is quicker compared to returning a string, true or false, whatever. Okay, so returning a Boolean value is quicker compared to returning uh, some string. So that is why this kind of development was made in Redis. So one indicates success. This particular key got deleted. If you use key star, you will not see the workshop string. Workshop string. Now this is set get delete the key and uh, like ping command purpose is whether Redis is working properly or not. Suppose let us say I came out. Okay, now like I am outside of Redis. Now, if I want to check Redis is working or not quickly, so if I use Redis CLI space ping, it returns form. This indicates that Redis is working. Okay, this is the ping command. So strings okay exists. Now set get del we have seen. Now whether that a particular key is existing or not. Like for example, just now I have created the workshop key from workshop data type string. So it is not there. Now let me create again workshop Redis and now let me give the same exists workshop. It returns one because that particular uh, key, workshop key is there. That string is there. So key space star if I give, that workshop is also there. So that is exists. Okay, we have completed set, get, delete, exists. Okay, is that uh, I mean TTL, all the things I will be covering. Now coming to hashes. Hash, for example, already I created two hash data types, data structures, student and this country. So first I want to see what are there in that particular hash. Like previously I mentioned in the while demonstrating the in SQL, not SQL, why Redis. At that place I have explained uh, you want to add more addresses or you want to add more phone numbers, then it is very easy in case of this kind of database, cache database. You just have to use the hash, create hash, and you insert or set all the keys or all the key value pairs, whatever you want. Okay, so now I want to see this particular key, what all the field value or key value, whatever you got, what all the key values or key pairs are there, I want to see. Serial number 4, name Subhash, course Redis, status active. So hgetar is the command. Now I want to add, as I said right in the place, I want to add address. Now let's set student uh, address. Let me put that right. Long address. Okay, it will throw error because I have given wrong here. And coming to this thing is also important. It's a pattern based that is also important. So Redis case sensitive. It is case sensitive. I will explain 1 minute. Redis address workshop. Okay, only adding one key value there. It return one, which get all student. So address Hyderabad has been added to this particular hash. Okay, now as I was explaining, case Redis is case sensitive. Okay, if now what I will run h data space student. This will fail because here S is capital. I am trying to search for small, starting with small s. Okay, so this will, I mean, fail or empty, what you will come. So the point is, this kind of is not there. This key, the key that we have created or the hash we have created is starting with capital S. This is H set, H data, and multiple set. That is also there. Okay. Uh, when whatever you give, okay. Work address one is not there. One, nine, nine, and work address. Okay. Now which then okay, phone number and work address, both we added in single go. In one go, we added both because I use the HM get. HM get stands for multiple, sorry, HM set stands for multiple set. Multiple things, multiple key value there I have set up in one single go. HM set and deletion. For example, uh, so and the pattern based that also I will explain. Actually, when we rush it, we miss many concepts actually. I mean, let us see how it goes. But if we continue, all the topics, everything will be covered.
Yeah, yeah, that's fine. If like if someone is completely new for them, it will be very helpful, right? If we go slow only, they'll not be able to catch.
Uh, 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 but in your case, you already know all these things.
Yeah, yeah. For
And
my case, I know, but like if someone is a beginner, right, for them it will be very helpful.
so all these things, now I want to delete a particular, just like we use del for strings, similar way here hdel, hash del, delete. So I want to delete. So phone number was, I have deleted the phone number from that hash. The phone and phone number I have deleted. Okay, so delete is done. Get data. That's it. Pattern based thing. So, okay, for example, I want to know the length of, I mean, name how many characters are there. H, length, and student. Acha. No, here it will give the entire hash. For example, total six are there. It seems. I mean, because 12 are there. If we do by two, it will be six, right? So integer six will come. Total length of that particular hash variable is six. That is h length. Now h keys. List out all the keys of that particular hash variable. So serial number, name, post, status, address, work address. List out all the values for that particular key. Then HVAL. So for Subhash, Redis, active, Hyderabad, high density. Okay, this is HVAL. And increment. For example, serial number 4, I mean serial number we don't increase generally, but salary. So let me say student salary and let me set 25 or something. Okay. So I am setting the salary 20,000. Now I want to increment. So increment H-I-N-C-R, okay, increment and how much? 10,000. So salary becomes 13,000. So previously it is 20,000. I used increment by and salary increase it to 10,000. Similar way, you can increase the floating point also. I am also, I mean, if there is some redundancy, I will also skip. So just like how we have incremented the integer, same way for float also we can do the increment. How? Like this is the command HINCR by float. Using this HINCR by float, we can increment. And same way that exists, we have checked whether that key is there or not. Similar way, H exists. Student name. Is name present? Yes, name is present. Or like I will give some other. Now phone number is not there, right? I will give phone. It is not there. It is just 0. So that is which exists. And STR, okay, all these things are now actually these can be learned. Self-learning also it can be done for these things. So let's change data. So let me already one list is there, right? What is that thing? Country. So I want to, it will be this one data type if you know. Remain, uh, so this high level theory I will complete and then we will build up. So list generally you can list is nothing but array or which we learned in C in BTech first year. We can insert from the left. I mean basically we will have two operations, push and pop. And that thing can happen both from left and from right also, right? So uh, let us say you have first inserted a country called India, okay? Or let us say first you have pushed uh, Russia, let us say, and then you have done the L push. Then what will happen? India will come on the top and Russia will go to bottom. Okay, next that is how it happens. Okay, so uh, and the indexes, what will be the indexes, right? For this one, it will be 0. For this one, it will be 1. And as far as negative indexing is concerned, this one will have -1 and this one will have -2. Same as Python. Okay. So let us see that thing here. As range of 0, 0, I got Norway. I mean, this list already I created. So 0, 2, -2. Total 2 countries are there, Norway and India. Okay. So as I said, here how this -2 has come. Starting is 0. Here I can give 1 or -2. It won't make any difference because this is positive indexing, this is negative indexing. Okay. So L push means you are pushing from the left side or top side, and whenever if you push the another country, whatever country, okay, if you push UAE, then UAE will come in the top, and now this will have the 0 indexing, and this will have the 1 indexing, positive indexing. This will have the 2, and as far as the negative indexing is concerned, this will have -1, this will have -2, this will have -3. Okay, that is how it works. So now let me do a push country and UAE. Okay, this is oh, okay, no issue. Um, okay, -3, we exceeded. Okay, great. So as I said, this is I give negative indexing here. 0, sorry, minus just a second. -1, -2, -3. So this is the reverse, right? In I forgot. This is the indexing. This will have -1 negative index. This will have -2. This will have -3 negative indexing. So now when I now like first I want UAE, Norway, and India. So how it will come? -1, -2 till -2. If I give India will come. If I give -1 till Norway only it will come. Now -3 till if I give -3 till Norway it will come. So this is the, I mean, we can execute and, but this is the concept. So L push, if you do, new countries will be pushed from the top or left. Okay, whatever you call. But because generally, while explanation, it will like we will be explaining like this: L push and L pop, R push and R pop. Okay, and L range, L Z, all these things are there. Let me say these many things are there. Push X, L index, B and pop. Okay, so the concept is if you are doing L push, the elements or the elements will be pushed from the top or left, whatever you call. And if you do R push, the elements will be pushed from right side or bottom. And how the indexing will be assigned? The top one will have 0 indexing, and from all the positive indexing will be incremental 0, 1, 2, 3, 4 like that. The bottom one will have -1 indexing, and it will keep on decreasing minus every single element. That is how the Indexing is the concept behind lists. Okay, I am winding up the session for today. So let me start the recording. In case of strings, we have get command, and in case of get and set for reading and writing. In case of hashes, we have hget, hset. But in case of lists, we will have L push. Okay, like I think I already demonstrated, but however, let me quickly give you an overview. Yeah, L push and key. Let me workshop. Okay, in that I am adding like let me add just serial numbers 1, 2, 3, 1, 2, 3, 4. Okay, I added two integers in the workshop list. So how to read this one? L range. Okay, L range is the command to read the elements in the list. For most of the data structures, it will be range only. I mean, like for list, and later we will be discussing the strings, and after that, other data structures. For all these rest of the data structures, it will be range. So workshop key and start stop. So since two are there, but in general, if you give just 0 and -1, as I mentioned in my last session, like positive indexes and negative indexes. So negative indexing from -1, it will go to top, and like that. For positive indexing 0, 1, 2, 3. 0 and -1, we will get all the elements in that particular list. So L push. Similarly, now let me quickly do R push, like from right side. Okay. Then the element will come at the bottom. It will not come at the top. Let us see. Okay. Let 1, 1, 1. Okay. Okay. So that is the element has come at the bottom because we have done the R push. So L push, L range. So these are all the lists, and I will give the, I mean, attach the full notes or and PPT, everything I will share. So remaining comments you can practice offline. Now coming to, yeah, for example, I want to pop this particular element, triple one. It is okay, pop and workshop. How many elements? Here we don't mention the the exact value in that particular list. So I want to pop two elements, 1, 2, 3, and triple one from right side. So these two got popped. Next, if you give L range, only 1, 2, 3, 4 will be there. So this is list. Now coming to streams. So streams is very important. Before we go into streams, some important concepts needs to be discussed. Streams is a log-like data structure. Streaming is everywhere, right? Like for example, whether you use IoT devices, whether you use the sensors, whether you use web analytics, or whether you use social media, in all places you will have the, I mean, streaming kind of thing, like data coming in huge, I mean, streams. So to handle this kind of streaming data in Redis, we have streams data structure. So streaming is everywhere. I mean, why streams is more, I mean, what is the difference between list and streams? In case of streams, there are, it is a log-like data structure. Okay, and I can give n number of examples wherein you can, like I already mentioned, right? Like for example, in case of web analytics, in case of social media, in case of many things like IoT devices, sensors, wherein you will find this kind of application, and Redis streams will provide this kind of thing. However, there is lot of advantage in Redis streams. For example, in case of For sorted sets, the commands will start with Z. For streams, the commands will start with X. For sets, the commands will start with S. I mean, these things are easy to remember. For streams, get already you know. So for hashes, H. For other variable or other data structures like sorted sets, streams, these two are little, I mean, need required to memorize. Okay. So sorted sets Z and streams it is X. Now, what are the things important points to be noted when we are discussing streams? Streams is a log-like data structure and it has wide range of application. Let us say one example. You can easily imagine, yeah, in case of lists, so the important application for streams is producer consumer, which Kafka also, Apache Kafka also provides that kind of producer consumer solution. Let me give some simple example by which you can understand. For example, in cultural phase or technical phase, something these things will be happening in regular scenario. So, and you may I mean, there is some kind of registration which is required outside before entering into auditorium, something like that. Some technical symposium, something like that. These things will be conducted in college. It's a simple example. So now a huge number of audience are coming, and the how will you handle that kind of situation? The point is the same person should not come to that particular, like for example, let us one person registration, for one person registration is already over, and that person should not become like, I mean, so consumer one, consumer two. So consumer one already completed that registration. So consumer two will should not be reading that kind of thing. Okay, should not be reading that kind of thing. That is the thing. And like even in case of, I mean, flight tickets and many places, this streaming application will come. Okay, and so multiple producers or single producer is sending the data, and multiple consumers can consume the data at the same time. In case of list, also it is possible, but it is little expensive. You can, in case of list, you have to do with L index. Okay, but then it is little more expensive to implement. So this is, it has a wide range of applications. So producer consumer is also, basically it is called as consumer groups. Okay, consumer groups, this also Redis streams will facilitate to solve this kind of problems. Generally in real time, mostly Apache Kafka is used. However, but Redis streams also plays very crucial role, and many places Redis streams also was also implemented. The difference between that thing, Apache Kafka and Redis streams is in-memory database, whereas Apache Kafka, it writes on the disk. And in case of Apache Kafka, that is 100% durable. In, I mean, even though Redis is in-memory database, we have the persistence mechanism, right? It also like which will be coming later on through RDB and AOF, like Redis database backup and append-only file. We are also writing into the hard disk. But however, around 70-75% cases in real time, Apache Kafka is generally preferred. But Redis also has a very, I mean, important application in this scenario. Now, I will quickly now let me show the commands quickly. Yeah, these are all the streams that are present, I mean, currently available. I mean, my stream is available, but it is empty set. So let me create one stream x add workshop, or I will mention um, work underscore stream, let us say. Okay, this one is optional, so you can mention, you can start now field and value, serial number 1, name Subhash, think I have to put okay, whenever you create a particular stream, it will return the return this kind of ID. It comprises of timestamp and combination with sequence number. Now let me add one more thing. See here, again timestamp is changed and sequence number. Now the why Redis is preferred, I explained, and one more advantage of Redis is it uses the radix tree. So in case of Redis, there will we it uses radix tree. Radix tree means like it will come in the DSA, data structures and algorithms. We have like a binary sort, binary tree, and many things are there, right? So here I am not going into detail. How much is required, only that much I am sharing. Like for example, let me write here. Okay, let us say our key is 123 and like 1 Subhash and 124 2 Chandra. So if it is like this, how the radix sort will interpret, I mean, how it, in the background, how, I mean, the Redis streams uses the Redis radix tree. So one, whenever it can encounters two, probably in this case, it can consider both both 1, 2 as the root, right? Because 1, 2 is same. In real time, it will consider like that only. But however, for your understanding, like it can become like this 1, 2. So here 3 is there. 1, 2, 3. And no. And 1, 2, 4. So like that. So now the element here it is 1 Subhash is there here. Here 2 Chandra is there. So it doesn't need to traverse the whole, like I'm not still not going into details, but if you remember, we will have all these things in data structures, time complexity, and all these things. Okay, order of and order of like that. In case of
Yeah.
yeah, in case of radix tree, it will be order of log n. So it doesn't need to, like in case of list, it has to traverse, like if I want to access the 5000 element and you are at the 0th element, it has to traverse entire thing. But in case of radix tree, it doesn't need to sorry, in case of redis trees, it uses radix tree and it doesn't need to traverse the whole entire string. So that is one very big advantage of the redis streams, and it is very fast. So it can quickly go to that particular, like I mean very few, I mean nodes it will be traversing. So that is the reason why now Redis streams is very powerful. Now in this case, probably I mean exactly what happens in the background we do not know, but this is the underlying concept. Okay, my screen share still not coming. Yeah, but anyway. Okay, so here X range. Okay, now one, if you see 177595 till here, it is common for both the IDs. Okay, so this will consider probably the root, and here the branching will start. All the branches and all will start here. So what will happen? The searching everything becomes easy. So that is the important point in. Now all the commands are similar somewhat, like for example same as the lists, I mean not same as the list, yeah, but it is little different in the sense Like in case of strings, we have get and set. In case of hashes, hget, hset. In case of lists, lpush, lpop. In case of streams, it will start with x. So this is xadd. And now to read this thing, you need to use xread. Like again, let me put so xread. Uh, my stream here count means, like for example, I inserted 2. If you give 1, then it will only read 1, but this count is optional, and this block is also not optional. I will come to this thing. So first let me quickly read and the key. Where will I go wrong? Exit streams, my stream. um, Acha, acha, dollar probably. Let me pick. Now this is when we use the consumer. Okay, no problem. Xread streams key ID. Let us say I remember the key. So it is the range last one. So okay, no issue. We will see whatever gaps. So Xread streams my stream. So in this name, Subhash name is there already. It is there, and these things we have inserted, and these things are already there. Okay, and these things we have recently inserted. Name Subhash, name Chandra. Now Xread is the command. I mean exact syntax. Also, it is not difficult. So there is some gap actually. No problem. So Xread streams my stream. This is how the syntax will go. However, the important point here is if you want to implement the producer consumer, okay, then like for example, I will quickly create one. This is the my stream. Okay, now X already commands are there. Let me quickly copy paste instead of yeah. So like now I am creating a new consumer group. Okay. Um, okay, no issue. I am creating a new consumer group. Let me change the names. Try to unnecessarily. Okay. Okay. So I am creating a new consumer group, right? Like I mentioned one example. What is that thing? Like some in case of some kind of event which is happening, where you will get a lot of people coming in, and same person should not go to the other person for registration. Okay, like that. So when there are multiple consumers consuming, so whatever, yeah, producer consumer thing. So that will be possible through Redis streams. Now I am creating one creating it one group. The arrow group command requires a key to exist. Okay, okay. Now let me change the to my stream. So I am creating one consumer group named officer group for this particular streaming of data. Okay, consumer group got created. Now uh, I will try to read it from multiple producers. It will become clear. Okay, so this block is something, this is in the form of milliseconds. 360,000 means 1 hour, like 360 seconds, no, not 1 hour, 6 seconds or something like that. So 60 seconds, 60,000 means it will be 60,000. It will be 60 seconds. So 360 seconds, it will be 60 seconds, 1 minute, 6 minutes. This block 60,000 is 6 minutes. I am just changing it to 1 minute. Okay, 60,000 milli. This is in the form of milliseconds. I am holding, like I have created a consumer group and I am blocking it for 1 minute. This is like I mean simple. Here this is my capitals. For this particular Redis stream, I am creating the consumer group. And after I created, now I am trying this, I will get probably 120. But yeah, no problem. Within 1 minute, I will be able to do. So in this, I'm doing this. Let me not, first let me quickly change the consumer one, consumer two, officer group. Okay. Okay. So I am trying to, this is one consumer. Okay. 1 minute I have put the block. So it will wait for 1 minute. Now I am creating another consumer. Okay. Now I will quickly add this one, name ABC. Okay. Yeah. So I am quickly adding one new thing in my stream. See, as soon as I added this consumer group, I mean that particular piece of data went to this consumer group. Now let me add another thing like name ABC, DF equal. It went to this consumer group. DEF went to this consumer and ABC went to this consumer. So in
So
the
how we
same
decided like which consumer group it has to take? Because the group name we are not specifying, no?
group name we have mentioned, officer group we have mentioned.
Okay, but in
In
that
both,
command, in add command, we don't have, right? Or it is there.
yeah, in the
That I,
add command, we are just putting into the into the stream. Okay, we are
now
just
second one, how it went to consumer group two, or it first one will go to one,
it
second one will go to
randomly it will go. I mean that
randomly
is the
picks.
way of
Okay.
streams. Streams, that is the
Mm-hmm.
way they work. I
Okay.
mean, for a particular stream, you create a consumer group. Once
Mm.
consumer group is created, I mean, when you add the data and how many consumers are there, those many consumers started accessing the data, and the same uh, value will not go to the different consumers. So that is how we are achieving that. I mentioned, right? Like for example, that person already got registered, or
Mm.
already then he doesn't need to go to again another place. I mean,
Okay.
bifurcation like that it happens. So this is the one. I mean, even in case of like, for example, we swipe the ID card in office, and also through mobile we enter true time something. How all these things are getting into, I mean, how the data is getting processed in the backend. Probably, I'm sure Apache Kafka they will be using mostly. Like that is now the producer consumer problem will be solved by these things, Redis streams or Apache Kafka or something. So both work the same way. So this is the way. And I guess probably 1 minute completed. So now, yeah, I mean, this block is something within that 60 minutes, you are blocking that thing. Let me add quickly. It added, but so within 60 minutes, beyond 60 minutes, that consumer will not be reading that consumer group. So this is the block time I mean, how many number of seconds. Okay. So now coming to, yeah, I mean, there are few more things. Here, consumer one has read that particular which we added in the streams. But I mean, let us say consumer 2 did not he process that particular data. Okay. In that case, we proceed with the XACK command. I mean, XACK command stands for acknowledgement. Like, I mean, once you execute that command, I mean, no need to repeat actually. I will share all these commands. Once you execute the XACK command in consumer 2, let us say, whenever the data is processed, it will send the acknowledgement to the consumer group in the consumer group. Then to the producer, you can say. Once the acknowledgement is received, then you can make sure that because when you are running in the real time, where in the client server architecture, there is a possibility of server getting crashed. So in those cases, you might need to implement these XACK, acknowledgement, expanding, all these things you might need to implement. Like for example, here the server or the node got crashed, and I mean, whether that particular data is processed or not is not known. So if you run the XACK command, automatically the acknowledgement will go to that particular producer or to the server. So that particular thing is processed, and from the here side also you can also check if anything like pending, like 1 minute. Any pending things I have to registrations or whatever. Here in case of tickets, airline tickets kind of example, this is what actually. So any pending things are there which not processed, then you can check this here. Command 7 with args in my stream or finding. I mean, yeah, it will work. So minus and plus both are like these two include everything. Like whatever pending is there, I want to see. Or if I want to see only one pending, accordingly you need to change the minus and plus. If I want to see two pending things, three pending things, accordingly you need to change the minus and plus. Now similarly exclaim. So these are all the same fall in the same category. Now sets. Sets are like just like in Python or any other language, set will contain the unique elements. So let me quickly. I mean, comments are easy. Same. Quickly I will show. So. I don't have any set created. Like let us say now bootcamp. Okay. 1, 2, 3. How many whatever you had? I added 3 in the bootcamp set. Now to read that thing, same yes range. Okay. So, this numbers, yes, numbers here. Okay. T, B, C. Okay. How many members are there in that particular set? 1, 2, 3, 3 members are there. So similarly, all other things are also same. Like for example, I want to remove the third person. Okay. BC 3 and I think so. This is how I 3 got removed, and if you see 1, 2 will be there. So SRVM S members, and if a particular member he is member or not. Okay, for example, 2. Yes, it will return 1 because 2 is the member. Now, if you return 3, it will return 0 because 3 was, we deleted the 3 and 3 is not the member. Now, uh, here, these are all very simple. And even if you try it, you can be able to. S card means total. Okay. Yes, card is total. How many are there? 2 are there. So 2 it will return. Okay. And the remaining things, S inter, S union, S diff store, and S union store. All these things are like, if you in your mathematics, if you are familiar with the sets, it is very easy. Like you create another set. Set 1 is containing 1, 2, 3. Set 2 is containing 3, 4, 5. Okay. Then when you try this particular command as union, it will give 1, 2, 3, 4, 5. Just like in Oracle, we have union and union all. Union all will give the duplicates, but set will not contain duplicates. So it is same as Oracle union. It will not give the duplicates. So union will give 1, 2, 3, 4, 5. And diff means A minus B. That is there in the A set and not in the B set. What are the things? 1, 2. I mean, we can execute, but I'm quickly concluding this thing. Like set A will have 1, 2, 3. B will have 3, 4, 5. So union of the set, yes, union, if you do it, it will return 1, 2, 3, 4, 5. And union store means it will do the union and store in a different set. Okay. Next, inter. Inter means intersection. It will return 3. Intersection, only one element is there. And inter store, 3 will be stored into a separate set. Now diff. Difference means that which is present in A and not present in B. It will be 1, 2. 3 is common. So 1, 2 will come. Depends, if you give the first set A and next set B, it will give 1, 2. If you give B minus A, that which is present in B, not present in A, which is 4, 5. 4, 5 will come. So same thing, diff store, diff, diff store 1, 2 will be stored into a separate set. So all these things are extremely simple and easy. If you practice once and if you get the output, then you can, I mean, no need to, you will not forget again. So next, coming to sorted sets. What is difference between sets and sorted set? Only one thing, sorted sets, you also have to give the score. Okay. And it starts with Z, right? So, okay, let me create one sorted set. Key will be, just now we created bootcamp. Now I create BC underscore sort. Here, what I will do, 1, 2, 3, 1. Okay, first is score. No, Okay, probably. First one is score, next one is member. I am giving 2 score for 345. I mean, these are, I mean, previously example which I told is within same set. Okay, I think it should be. Okay, so 2 got added to the sorted set. And if you want to see those things, the command is zrange and vc underscore sort start stop. Okay, I will give 0 minus 1. Then both will come. But if you want to see with scores, for this 1, 2, 3, I have given score 1. For this 3, 4, 5, I have given score 2. Then you have to add this with scores. Okay, for 1, 2, 3, score is 1. For 3, 4, 5, score is 2. That's all, I mean, sorted sets. Same as sets, just the score also we are giving input. For a particular, in the set, for a particular element, we are also giving the score for each element. And if you want to see with scores or without scores, if you give with scores, it will display with scores. If you don't give with scores, it will display without scores. Now, yeah, increment by, if you want to increase the score of a particular element, you can use zincr by. Okay, BC sort. And I want to increment by 1 for 345. 345 is currently 2 is the score for 345, and I want to increment by maybe 10, let us say. Okay, then the score becomes 12. Now if I execute this previous command, so for 345 the score becomes 12. So all these things, z count will give the how many count of that all the elements. So rank is different from score. Scores is what we are giving. Rank means it is almost like indexing only. Okay. Okay, 1, 2, 3. It will be 0. If you give 3, 4, 5, it will be 1. I mean, the way we discuss the indexes in list, the rank will also almost act the same. So reverse rank means reverse it will give. Okay. So this is all these things. So so all these other commands also same, these are different data structures in Redis, geospatial indexes, bitmap, hyperlog. For all these things, I will give the detailed commands also, detailed nodes. Probably I will need to just consolidate. I will just need to just take half an hour and consolidate. Uh, Actually, all got scattered. So yeah, that's all with this data structures. Quickly, I will, yeah, Redis has a persistence mechanism because since Redis is in-memory data structure, there is a possibility of losing the data. So Redis has a persistence mechanism. Let me quickly demonstrate the publisher subscriber. What we explain the producer consumer is different. That is real-time application. But it is something like radio station, right? I mean, or some YouTube subscribers and all. I mean, like anybody can, those who subscribe, they will get that particular information or data. Like what is the difference between radio station means broadcasting. Okay, so now it will be not take much time. That's why but this has to be completed or this has to be explained once. Simple commands only. For example, uh, publish channel, channel name, what I will give channel. So it is previously I have not started. So this message you won't be able to see. Now if I start publishing, you will get, I mean, the subscriber will get the message like new course. Um, okay. Yeah, I have given new. Okay, probably a double quotes. Hmm, new quote. So because spaces means it will not understand it. So if you are giving spaces, you have to put in double quotes. So whenever you are publishing anything to this particular channel, the subscriber will get that particular thing instantaneously. It is like a broadcasting radio station. So everybody, whoever subscribed, they will get that particular message. Uh, like the producer consumer will have a deep application compared to the subscriber, publisher subscriber. This will, I mean, where we will use in case of blogging, in case of subscription, I mean, channel subscriptions, blog subscriptions, all these things. So this will not have the, I mean, it will have its own utility, but this is how it will work. So now if you have multiple subscribers, they will also get this. Okay, now he also started subscribing the channel. Okay, now let me publish. Welcome. So both subscribers will get the message. Unlike the producer consumer, wherein the message will not be duplicated and redundancy will not happen. But in case of publisher and subscriber, the message will be broadcasted, and whoever is subscribing that message, they will be able to read that particular message. Now persistence. It is RDB is like a snapshot to hard disk in a particular duration, like every 5 seconds or every 10 seconds, depend every like some interval, that particular snapshot will be written to the disk. But AOF is not like that. AOF is a ledger kind of thing. Like whenever some write statement comes, immediately it will log into the AOF file. Like for I mean, so I mean, yeah, because here also there is a possibility of losing the data. You have given some interval and like 5 seconds, and let us say some server crashed or 10 seconds, and server crash or something happened. You will lose that data in that particular duration, right? Even if you restart, like Redis may not be able to access that particular thing. But however, in case of AOF, it will be append only file. Whenever a write statement or these things are triggered, it will log that particular entry into the AOF file, append only file. So that is why it is super fast resource and manual backup. Crashes between snapshots, you lose all the data since the last photo. So it has maximum durability. You lose almost zero data. The file can become very large. This is the one disadvantage of AOF. If, like, for example, just now we have entered multiple commands, and AOF, um, like, file will become very huge, and Redis restarting will take can take time, right? File can become very large, and restarting takes longer because Redis has to replay every single command from the log. This is the Redis persistence mechanism.
So these two are the persistence mechanism, like these are the different mechanism, right? RDB and AOA.
Yes.
Okay.
Now coming to very important, which is master-slave architecture. So, and high availability. So, master-slave architecture in case of Redis, like for example, uh, this kind of issues wherein data may get lost. So in those situations, how to handle this situation? So master slave architect, let me know. Master slave architecture, master slave is one solution. What happens in the master slave? Like when you create the replica of a particular master node, the slave also has the same snapshot of the master. How it happens? Already in a high level or something I explained in the last session. When the new data was added into the Redis immediately sends that particular, Redis sends its entire contents of the RAM to slave, and it is up to the slave's responsibility to, clean the disk and uh, write that particular file into its RAM. This is the, sequence happens. Now let me quickly show you the configuration and all. Okay, let us see. I am going to conclude quickly. Let us quickly see the comments. Uh, Very short time. I will try to cover maximum number of comments. Okay. See here. We have. Just for demonstration. After this, I will be stop these long instances. Okay. This is my where I would like to configure the my master node in this particular server, and I want to configure my slave in a different instance. So this is the, just remember this naming convention, slave, and another slave, Linux slave 2. This is my another third slave. Now, in order to configure this kind of master slave architecture, so first few things are important. One is folders which you need to remember. What are those three folders? One is /etc/redis6 and /var lib redis6 /var log redis6. These are the three folders which you have to remember. This is for configuration, and in a production kind of setup, it will be like this only. In case of if you, because anyway I'm demonstrating on the live production setup. So if yeah, for this one, where log redis6, these are the three folders which we have to remember. This is for configuration, and in a production kind of setup, it will be like this only. In case of if you, because anyway I'm demonstrating on the live production setup. So if yeah, for this one, uh, yeah, here it will be logs, and correct. So here we will have the backup. We don't say backup, yeah, RDB persistence. These are the three places which you have to, three folders which you need to remember. /etc/RD6 Redis6 will have the configuration, how you are configuring the Redis, like and how you are configuring the Sentinel, like which is coming later on. Like, I mean, why we are going into that thing? Like, even in case of master slave architecture, let us say the master has gone down. I mean, server one got crashed. And what should happen? Uh, Immediately, like what we discussed, in case when we configure the master slave, all the rights will go to the like write operations. Those will go to the master node. All the reads will happen from the slave. That way, we are achieving that kind of efficiency. In case of server client, all the requests keep going to the same server, and there is a lot of overload on that particular server, and there will be a lot of latency issues or server crashes. All these things will happen. But if you like to a solution for this is creating a replica of that particular master and keeping the same copy in both master and slave. But in master and slave, again, there are some challenges. If the master goes down, then there has to be some manual activity to, writes are stopped, only reads will be there, right? From slave, only reads will be there, but writes are stopped. So for writes to not stop, like the slave, so that is the high availability solution wherein we use the Redis Sentinel. Okay, yeah. So in this currently what I am showing is also not a full production setup. Uh, we will see, but in real time it will be working like that. Sentinel is a separate process running uh, aside from the Redis. It will have its own configuration. Okay, it will keep monitoring both master and slave. Okay, for example, if you see Sentinel-1 is monitoring Redis slave, this master, and this slave. Redis Sentinel-2, it is monitoring this slave, this master, and this slave. Sentinel-3. So each Sentinel is monitoring both master and slave. Now, what all the things that Redis Sentinel does? But why it came into the picture now? In case of master slave architecture, when the master goes down, then you are left only with and all the writes are getting stopped, and there has to be some manual activity wherein either master has to be brought up or slave has to be made a master. So for that one, like Redis Sentinel will solve that kind of solution. It is a separate process running and it will do these three things. It will do the monitoring, it will do the notification, and it will do the automatic failover. It will monitor both master and slave whether they are working as expected or not. That is the first thing. Now, second thing, notify the other program or system administrator via an API when something goes wrong with the monitored instances. If something is wrong, then immediately Redis Sentinel will send the notification. And automatic failover on master failure, Sentinel promotes one of the slaves to master, then make the additional slaves use the new master. Okay, on master failure, what the Redis Sentinel does, it promotes the slave to master and then make other additional slaves using the new master. Other slaves will be using that particular as the master. So there is no latency here. I mean, it will act like a full in-memory and caching mechanism, all these things, whatever the functionality as part of system design, there is no latency and uh, application will respond immediately to the end user. For implementing this, we have we have to create the master already that is in the Redis configuration, and for the slave we have to configure using the replica of. Now quickly what I will do, Actually, already all the setup is already done. Master slave, all these things. Okay. Now what I will do? Hmm. Okay. Info replication. This is the command to see whether already some replication is happening or not, like already master slave architecture is in place or not. So let me execute. I'm executing the info replication command in both master and slave. AUTH. This is the password which I have set up in the Redis configuration. Okay. Okay, it is slow. Something. Okay, see here. Currently, this role is master and connected slaves one slave, it is already connected. So if I see the same info application here, it will say this role is slave, and I already executed the commands. I will explain that shortly. So its master is the particular public IP, this one, 13, 62, 20, 42, and 164. And this is the port and master link status up. This is the most, immediate thing that you need to check for when you are configuring the Redis master slave. Master link status is up or down. Now what I will do, quickly, I will run this command because I have already configured before we join replica of no one, just for demonstration purpose. Okay, I have executed the command replica of no one. Now let us see the info replication. See, this is itself is a master node, and connected slaves are 0. Okay, this itself is a master. Now I'm just starting again freshly configuring the master slave. Now, if you want to configure master slave architecture configuration, okay, because previously in my master password as was configured, so yeah, so these three things are required. That's all: IP address, port number, and password. Now let me quickly configure the. This is I am starting from the scratch, like in the sense this is itself is the master. Now I want to configure this as slave and to this particular master. Okay. Uh, for your more understanding, actually, this is a GPU kind of thing. G4DN large is very huge instance. These are small instances. So this one is a master. Okay. So this one is a G4DN XLR means it will have huge RAM and it is a GPU, not even CPU. Previous cases, CPU will handle certain things like computation, all these things. GPU will handle graphical related things, and CPU will not handle that thing, and GPU will not handle that which CPU takes care. But the latest GPUs, like in case of later, if you are interested in ML or AI, so latest GPUs, they can handle both computation, whatever CPU performs. That also, that thing along with the graphics related things with the GPU does, uh, like we can also handle the CPU computation related tasks. So I just changed this instance for our upcoming modules. So now this is my master. Okay, Checkor of Linux, where I am trying to what I am trying to do, configure the master, and remaining two are my slave nodes. So how to configure? So by default, now if I see this here, slaves, connected slaves will be 0. So simple, like a few commands only. You just have to remember. Let me clear the screen. I am delaying you, but I will see. Okay, let me try to close. Uh, this is master and connector slaves are 0. So what I told you, like if you want to configure a slave, a slave, you just have to do replica of. Just remember this info replication and replica of. These two are sufficient. Okay, host. What is the host? This is the public IP address, and it is listening to 6379 port number. Redis has default port number which is 6379. Okay, default port number it will be listening to. So once if I do, immediately it will not happen. Why? Because the password setup is done already. So you have to ensure this thing you already set, like not set. Let us see. Get already I have. Hmm. So in my master node, okay, okay, let me see. Sudo hyphen I we have to give. Okay, why? Because the Redis seeks like only for super user permissions will be there. Therefore, when you give hyphen I, it is like a switching to the root, super user switching to the root. Okay, now it switched to the root, this hash symbol has come. Now I will be able to access these three folders which I mentioned earlier. Without this sudo hyphen I won't be able to access these folders. So now if you uh, these are the places where you will find the configuration redis6.cnf and sentinel.conf. Now, yeah, if you see here, suppose you want to, because once you work in real time, you have to, this is the place, require pass is a keyword. We cannot change anything. So this is the place where check over, I have set up the password for my master node. Okay. I have set up the password for my master node at the rate 123. So now what I have to do, whether here it will be master AUTH. There it is require pass. Here it is master AUTH. These two are also simple only, not difficult to remember. So as I mentioned, this is the configuration file wherein we will be giving the require pass or some other
I mean, slave,
configuration.
what all the like that require pass I am aware, but what all extra configuration we have to add to activate in slave? What are the configuration? Can you show me once in
Sure.
slave node?
Hmm. In this is the slave, right? Just
Mm.
replica of port number and this thing,
Okay, we need to give the master port number and master
master IP
IP
address.
and port number. And what about the slave configuration file in that? Do we need to mention anything?
Yes, we have to mention. So info replication. Let me previously this is the master and connector slave 0. Now I did this for the master password I have configured and I replicated the slave to the master. So okay, response it has returned. Now info replication, if you see, role is slave, master is this master node and port number this one. This is the most important thing I told, right? Master link status up. Once this is come, that means this is acting as slave to this particular master. So with this master slave architecture setup is done with two nodes.
And we no need to like edit anything in the config file apart from this because these are the commands only, no? In config
Yes.
file, then nothing is required.
Okay. Yeah. So let me open one. But 93 KB. Um, Okay, let me do one thing. More important is lines 2000 only. So let me do this. Will I be able to read from top? Yes. So what are the important things? You have to ensure if it is bind is one important. Acha, it is still going down. Maybe. So what are the important configuration? Bind space port number. If in case by default it is localhost, okay, 127.0.0. So it is 2000 lines, right? Because it is confusing for me whether it is now the top part is gone. So since it is 2000 lines, let me read 1000 in one go. So what I will do, and let me give the spaces, otherwise where this head will come. Head hyphen 1000. It is 6.0 um, okay. Now, anyway, this bird is dead. So head hyphen 1000. Okay, so here BIND variable is very important. By default, if it is set to 0, I mean 127.0.0.1. Okay, yeah, I got 1000 first 1000. Let me see this one. Yeah, see here. I changed it to 0.0.0 because anybody can connect to me, something like that. But ideally, we have to ensure accordingly, we need to give the port numbers, sorry, IP
Okay.
addresses. So here by default, you will find 127.0.0.1 colon this thing, which means this is slave only, which means like, which means it is a local host. That means it is bind, Redis is bind to this particular slave, this kind of public IP, and nobody can connect to this Redis memory or Redis server, whatever. So this 127.0.0 want to change it to 0.0. This is one important thing. And uh, like that, few important things are there. Those very few configuration changes we have to do. That's it. And I have to do bottom 1000 also. DB file name RDB or dump.rdb. So okay, I should. This is the replica of master IP master port. Configuration file, or you can use the CYNFIG config command and set these things. Now, master username, these are the replica of, these are the important things. Okay. And yeah, remaining things are easy only. Yeah, priority 100, it should not be 0. Replica priority should not be 0. 0 marks the replica as not able to perform the role of a master. I mean, in case when you are implementing Redis Sentinel, wherein the slave becomes the master. When the master goes down, the slave becomes the master. And if you put Redis replica priority 0, it won't be able to become the master. So this is the important thing. So now to quickly wind up. Now quickly what I would like to show this replication. Yeah, replicate. Okay. Now for some reason this became slow. Once since I have executed that command, what is that command? Replica of master IP address space port number. Now if I see the info replicate, Acha, that also I have demonstrated. So this has become the master slave. Now the coming to the Sentinel configuration. Sentinel configuration, as I mentioned, this master slave has some disadvantages. What are the disadvantages? When the master goes down, writes will be stopped, only reads will be there. In case of, and there is some manual activity, but Redis Sentinel will do those three things: monitoring and notification, and the third thing, failover. I mean, okay, right? Whenever the automatic failover, whenever the master goes down, this will come up. So these are all the things, configuration things. Redis Sentinel, this has to be configured in both master and slave. Sentinel monitor, my master is just a nickname only. IP address and port number and 1, 2, 3. How many sentinels you want? Okay, that thing. And sentinel downtime master. If master doesn't respond for 5 seconds, sentinel marks it down. Master, if it is not responding for 5 seconds, then immediately sentinel so that master is down, that slave becomes the master and other slaves start listening to this particular master. Now failover. If failover is already in progress, sentinel won't try to start another for 60 seconds. Okay. Oh, yeah, yeah. Okay, okay. This is still not failover. This is down after. So all the 1, 2, 3 and parallelism. This is not important. These three are the configuration for implementing the Sentinel. Once with the master slave configuration and combined with the Sentinel configuration, you will achieve the high availability. Now I will demonstrate Redis high availability. First of all, I will show you how I have configured the master slave architecture. In my Linux EC2 instances, master slave architecture is already configured. So after that, and how the Redis Sentinel, which is like enhancing or which is implementing that kind of HA solution. Okay, all these things I am going to present now. Let me share my screen. So this is my master instance. Okay, 1362 242 164. Okay, and this is my second instance where I have configured the slave 1351 109 61, and this is my third slave, second slave 1350 250 31. So one master and two slaves, total three instances, right? So yeah, let us quickly see the how the master slave architecture is configured. As I mentioned previously, this is the place, this is the path where you will find the Redis configuration and Sentinel configuration. Okay, this is the path where the configuration files will be there, and this is the path, this is the in these files you have to configure both Redis and Sentinel. So there are various options, like if you want to require password, if for example to enter the commands, then there is a keyword require pass, and there is also master AUTH, master app. So these two you have to configure, and also there are other things, right? Like for example, bind, that is also one configuration. So like that, there are various things which you have to configure to uh, first of all master slave, implement the master slave architecture, and then implement the Sentinel, which provides the high availability solution. So let me now quickly, let us see how the master slave is actually working here. Okay, This is the command info replication. I have set up the password, so it asks me for password. So info replication, if you see, for this particular instance where I have configured the master, how we will configure the master, how to configure slaves, that is very simple. Replica of no one and replica of that particular master and port, that's it. So it is simple commands only. Now in this particular, this one is playing the role of a master, and this it has two slaves. Okay, that's all. Now let us go to the other instance. This is another instance where I configured the slave. Let us quickly see. Okay, so this is the slave, and very like important configuration or which we have to look to. Okay, whether this is replicating that master or not. This is one important thing. Master link status up. Okay, so it is up connection and role is slave. So what is the master host? 172.31.26.176. Okay, if you go here, 172.31.26.30 176. Okay, see 31.20. So they will communicate through private IP, not public IP. That is also one important point to note. Now let me go to third instance where I configured another slave. Okay, see, this is also slave and its master is same, the this one, 172 31 26 176, 131 26 176. Master link status is up. Okay, so currently now this and this, these two are the where slaves are configured, and these two are linked to this particular master, right? Now, as I mentioned earlier, already the Sentinel configuration is already done. So, few important points to note. So, whenever like Sentinel configuration also easy only, but inbound ports, okay, and so these things are important, like because these three sentinels have to talk to each other, right? So if, and the inbound port for sentinel it is 26379. 6379 is default for port for Redis. 26379 is default port for Redis Sentinel. Okay, now in your inbound, like let me quickly show you. For example, this is the master where I configured master, right? If you go to security groups and inbound tools, you will find the 26379. Okay, sentinel. So important point here is you have to configure the inbound ports 26379. So for the sentinel to talk to other sentinel, you have to configure the inbound port. Very important. Okay, that is one. Now another thing, I will mention just points to remember. Okay, now let me go to master, and I am trying to stop the Redis in this particular where master is configured. Okay, let me, how we'll do, systemctl stop Redis 6. Okay, okay, so I have issued the stop command for Redis 6. So now if you see, it should refuse, connection is refused because Redis is not running in this instance where master is configured. Okay, now as per the high availability, Redis high availability, what should happen as per the, I mean, Sentinel, what should happen? So the Sentinel, which is present in other two slaves, will quickly understand that the master is down. Now the, it will make one of the slave, either this one or this one, as master, and the other slave will connect to this particular master. Like if this is this slave was brought up to master, then this slave will connect to this in this instance, like that. Okay, so let me reiterate. So master is down. So previously these two slaves were connecting to the master, and now since the master is down, one slave becomes the master and the other slave will be connecting to this master. So previous situation, this is connecting to this master, okay, old master. uh, you can refer the video again, so it will become clear. Now since Redis is down here, now let us see the status. It, I mean, ideally it should happen immediately. This is slave, but the master host is different. See, the master host 172.31.969, not this one. 31, it is ending with 176. Okay, the master is 172.31.969, which is the private IP of the third one, 31.969. Okay, now let us see here. This has become the master, right? So this is how Redis high availability work, and how the Sentinel configuration will provide that kind of high availability solution. Okay, so originally this is the master and these two slaves, this one and this one, these two slaves connected to this master. But then in this particular master, Redis was brought down, and so immediately these two slaves were Sentinel process is monitoring, it will understand that the master is down, and it will bring up one of the slave to master, and other slave, this one, will be connecting to this master. This is how Redis high availability solution will work. So all these three very important configuration part is, all the three sentinels should talk to each other. That is the very important. If they are not able to talk to each other, they are not able to communicate, then you might not, I mean, the HA solution will not be able to implement. Okay, so regarding the configuration details, let me try to bring up, or if you need any clarifications related to how to configure all these things, you can mention in the comments, we will respond to your comments. Okay. However, this is the important high availability which is Redis is popular for, and using this there will not be any latency issues, or there will not be any uh, uh, server crashes, or these kind of issues are resolved by this high availability. Okay. Just two more points. If the high availability solution is not there, then when the server or master goes down, only you will have only the reads. Okay, slave from the slave previously only reads, and from the master writes were happening, all the writes. Okay, writes in the sense set command and h set and other things, add, l push, lists, and other where data structures where writes are happening to master and reads are happening through slave. But here, once the high availability solution, without the high availability solution, master is down, only reads are happening and writes are not happening. With the high availability solution, both writes and reads will happen, and without any latency issues. So if you want to check the logs, you can see here in this particular path, this is the slave. Okay, this is the slave, no issue. Not this one, where log Redis 6. Okay, I need to switch to so this is the sentinel log where you can see the all the status, like for example, Redis is starting, sentinel ID, monitoring master. Okay, this one, quorum one. So yeah, the sentinel started already.